Alright guys, welcome back. In today's video, we're going to be modifying my DIY surface grinding attachment. As many of y'all know, one of the most popular videos on my channel was a step-by-step tutorial on how to build a surface grinding attachment. This SGA has been doing an excellent job for me, and I use it on every knife that I produce. To date, it is the most useful tool that I have made for knife making. One of the largest drawbacks of this DIY surface grinding attachment is the constant power magnetic chuck. It presents two problems. First of all, the accumulation of metal dust on the chuck can be difficult to remove. I normally use a gloved hand to clean the chuck before using it. If this is not done properly, the flattening accuracy of the chuck can be negatively affected if the dust gets in between the blade and the chuck. The second issue with the constant power magnetic chuck is getting the blade on and off of it. When getting the blade off, you have to drag it off the side of the chuck, and this can scratch the finish that you just worked so hard to achieve. You'll notice that in many of my videos, I will tape one side of the blade to minimize the chances of this happening. George at Northridge Tool noticed I was having some of these issues while watching my videos and graciously sent me a new fancy magnetic chuck for my surface grinding attachment free of charge. My goal with this video is to show how this chuck from Northridge can be incorporated into the DIY surface grinding attachment build. If you want to upgrade your DIY surface grinder, make sure to head on over to northridgetool.com and call those guys to get yourself one of these chucks. I think they will be selling these chucks for approximately $350. In the spirit of full disclosure, I would like to reiterate that I got this chuck from Northridge for free. However, they are not paying me to make this video or to promote this item. So my first impressions of this chuck is that it is obviously a precision-made item, and that it is also pretty hefty. I end up weighing this chuck versus the chuck that we manufactured for the surface grinding attachment, and the difference is about 5 pounds. So keep this in mind when you are building your surface grinding attachment. If you will be using your attachment in the horizontal position, I do not think this is a big deal. The first step on the conversion is figuring out how far back I need to move the wheel. This chuck is around 1 3/4 of an inch tall, and I will be using spacers that are the same thickness as the stock I used on my first chuck. So the total distance I need to move the wheel is 1 3/4 of an inch back. I mounted the tooling arm into the vise on my mini mill and started drilling holes, starting with an 1/8 of an inch pilot and then working up to a 27/64 of an inch hole that I will be tapping to 1/2 by 13 thread. Since when I built this surface grinding attachment, my bolt was purchased from the hardware store and does not have threads going all the way up to the head of the bolt, I will be using a 1/2 of an inch end mill to countersink this hole. If I was to redo this project, I would have opted for a fine thread bolt that has threads all the way to the head. But in this case, I used what I had. To keep my tap nice and lined up, I go ahead and start the tap by hand in my mini mill with the tap in the chuck. This allows me to get the tap started in a straight orientation. I then finish out the tap by hand. This low-tech tapping method has done a very good job for me in the past with keeping my holes nice and in line. Now that we have the hole drilled, tapped, and counterbored, we will reinstall the wheel on the tooling arm. This wheel is an 8-inch in diameter, 3-inch wide wheel that was purchased direct from China, so it is not the best wheel in the world, but it has done a decent job on this surface grinding attachment thus far. The next step of the conversion will be attaching our new chuck to the sliding mechanism. In order to do this, we will be using some spacers made out of aluminum that was left over from making this original chuck. I have a 9-inch section of 1-inch thick aluminum that we will be making these spacers from, so I will be making 3 3-inch spacers. Here I am marking off where those spacers will approximately lay. It's worth noting here that there are obviously a few different ways you could attach this chuck to the sliding mechanism. I'm using these 3 large spacers because this is the material that I had on hand. If while watching this build you happen to have an epiphany on a better way to attach this chuck to the sliding arm, please put it down in the comment section below so that we can all learn together. It took about 20 minutes to cut out these thick aluminum spacers. I then used the belt sander to round over the corners and knock down the edges so that we don't cut ourselves during the rest of the build. To attach these spacers onto our arm, we'll be drilling some 1/4-inch holes through this 5/8 by 1/2 of an inch bar. This bar is what attaches the chuck onto the sliding arm, and then the sliding arm rides on those bearings that are attached to the table. You may notice that I have some marks on this bar that say no drill. Those spots line up with the mounting hardware on the chuck itself. These spacers will be mounted to this bar, and then the chuck will be mounted to these spacers. So we want to make sure that these 1/4-inch holes don't interfere with us mounting the chuck to these spacers. Originally, the chuck was held onto this bar with 3/4-inch fasteners. In this case, we will be putting 2 fasteners per spacer, so we'll move that number up to 6 total fasteners. Once we have these through holes drilled in our bar, we will be tapping the spacers to accept a 1/4-20 thread. This is what the bar looks like with all 6 of the new holes drilled. I decided to surface one side of the spacers. In reality, I don't think that this step is really necessary, but if you really wanted to have the highest level of precision, you would have squared up all 3 of these blocks on all 4 sides before mounting this bar onto them. Since in order to square up the chuck to the wheel, we will eventually have to grind the chuck, I don't think that squaring up these blocks is worth the time. So I got the spacers lined up with where they should be on the bar, and then used a drill bit through the holes in order to mark where I will be drilling and tapping a 1/4-20 thread in the spacers. I start off with a spotting drill, and then I drill a number 7 hole and tap to a 1/4-20 thread using the same technique that I used when mounting the wheel on the tooling arm. On the original chuck, I did not drill all the way through the chuck, since I did not want a hole on the side of the chuck that would be accepting the blade to get full of dust and dirt and things of that nature. But on these, I don't see a negative of drilling all the way through the block if you desire. Once we have all 6 holes drilled and tapped, I decided to do a quick little fit up just to see if everything lined up good, and it did. So this is what we look like thus far. So major shout out to Indiana Jones for this next technique. We will be transferring the mounting holes onto a piece of paper using a pencil, and then we will be transferring these holes from the paper onto our spacers. Once I had the holes traced out on a piece of paper, I took an awl, or a needle, and poked a hole right in the center of each of those holes, so that when I flip over this piece of paper, I will have a target to center punch. I used my light on the phone in order to line up the edges of my trace. Once I have the holes punched, I take the spacers off the bar so that we can drill them. Before drilling them, I measure the mounting hardware so I know what size holes that I need to drill. I will need around a 1/2 inch counter bore in order to set these cap head screws into the spacer, and I will need around a 310 thousandths hole for the body of the screw to go through. I also measure the height here so that I can get the appropriate depth of my counter bore. Now, I made a mistake when drilling some of these spacers. I am not showing my mistake here, but you will notice that there are some extra holes in the finished product. What I did was I drilled these holes all the way through and counterbored from the top instead of the bottom of the spacers. So my point here is just know what side you're counterboring. In this case, you will have to flip over the block, line everything back up with the last size drill bit that you used, and then counterbore the bottom side of the spacers, not the top. Happily, this was not the end of the world for my project. However, it's never fun to add a few hours to your build just because you're not paying attention. To counterbore these holes, I used a 1/2 inch end mill, and the head of the cap head screws were slightly larger than that, so I just took them down briefly on the belt grinder so that they fit into the counterbores nicely. Now to put this thing together, I lay the chuck down face down and then start attaching the spacers to it loosely. You can see that 2 of these spacers have 2 extra 1/4 holes in them, and that is because of the mistake that I mentioned earlier. I put the bar down and get everything lined up and snugged up, and then I use 2 1-2-3 blocks to make sure that everything is nice and square. I tighten up the bolt that I have access to, take the bar off, and then tighten up the bolts that were hidden by the bar. In this way, I know that the spacers will not move when I am tightening the top or the rightmost bolts on your screen. Once I have everything tightened up, I put the bar back on, get everything screwed in, and then tighten it up by hand just to make sure I'm not over-torquing with the impact driver. Next, we will slide our rail back onto the table. I like screwing in these little stops that I made out of horse mat just so this whole thing doesn't go flying off. I then bring the entire chuck assembly onto the rail and screw it on. Now that everything is nice and assembled, we'll give a little sneak peek here on how this chuck will work. With a large Allen key, you can change the poles in the magnet, or block the poles, so that the blade can come off easily and not be attracted by the magnet. Put the blade on, turn the Allen again, and it is held on tight. After a careful inspection, I noticed that the chuck was a little canted in relation to the wheel. Now I know I have to grind this chuck anyway, but I didn't want to take off that much material. So I have some 5/1000ths of an inch shim stock that we will be placing in between the spacers and the chuck in order to get everything lined up just a little bit better before we true up the chuck to the wheel. This did a great job in accounting for the bulk of the misalignment. With any homemade surface grinder, you will have to do some grinding to the chuck in order to make sure that the wheel and the chuck are square. To do this, I used a high grit belt. This is a Trizact belt that is around a 360 grit belt. However, I feel like a 220 grit belt would have worked just fine. To surface the entire 2.5 inch wide chuck with a 2-inch belt, I moved my tracking up and down so that the entire chuck can be covered. I would also suggest that when surfacing your chuck, make very small advances towards the wheel and make many passes at each advance so that you take off the least amount of material possible and also have the highest level of precision at each advance towards the wheel. So I'll be doing a test here in a little bit showing you the level of precision that this surface grinding attachment was able to achieve, but first I'll show you some glamour shots of me messing around with a blade blank here. The nicest part of this chuck, obviously, is being able to turn off the magnetism and wipe it clean with one stroke. So first we'll use the non-scientific sink cutout granite test. You can see that this blade did not move around when pressing on the blade at different spots. This is a pretty good indication that you're flat. In reality, for most full-tang knife makers, this is as far as you're going to need to go to verify how flat your surface grinding attachment is getting things. But I decided to put a test piece in a surface grinding attachment and really take my time with it, making about 20 to 25 passes per advance towards the wheel on each side. I wanted to see how precise, I guess, this thing could be. Now, I want to put this disclosure out there for all of you angry machinists watching this video. This is not an industrial surface grinder with a stone on it. I know that those industrial surface grinders can achieve a much higher level of precision, but for the craft of knife making, this thing performs very well. With this 7.5 inch piece, I expected around 1 to 2/1000ths of an inch total variance in the thickness of this piece from one end to the other. Now, you'll see in a second when I use the micrometer that we achieved a much finer level of variance between one end to the other. I'm not sure if the results I got on this bar are just lucky or if this thing is going to perform this well going forward. And like I said before, I took very small advances towards the wheel and about 25 to 30 passes per advance. So I spent a lot of time on the surface grinder for this test piece. A lot of time that I probably would not normally spend with a knife blank. But all that being said, this thing achieved, according to the micrometer, around 3/10,000ths of an inch over 7.5 inches. I went and tested some middle pieces here just to confirm the results, and that is what we got. I am obviously extremely pleased with these results, and I'm very happy with how this chuck assembly turned out. It is very nice to be able to turn the magnet on and off in between the different sides of your knife blanks and wipe the entire magnet clean. I would like to extend my thanks to George at Northridge Tool for sending me this chuck to outfit my surface grinding attachment. If any of you guys are looking to get a chuck that can turn on and off, go ahead and check out northridgetool.com, give those guys a call, and they can get you hooked up. So like always, until the next time, I'll catch y'all on the flip side.